Hey everyone, welcome to today's Explainer. Okay, let's dive right into this. If you follow astronomy at all, you already know the James Webb Space Telescope has been looking further back in time than anything we've ever built. But man, what it found out there, it completely broke our standard cosmological timeline. We're talking about a massive paradox that literally has astronomers scratching their heads. JWST is finding these absolute monster galaxies that, according to all our standard rules of physics, absolutely should not exist yet. So today, we are unpacking a radical, incredibly elegant geometric solution to this whole mess. It's called the ancient tide.
So, here is the crime scene. JWST peers deep into the early universe and spots stellar masses. We're talking 10 billion solar masses, already completely assembled at redshift z equals 10. Now, in standard cosmology, redshift z equals 10 means we are looking at the universe when it was just 500 million years old. To put that into perspective, that is barely an eye blink in cosmic time. Under our normal assumptions, building a galaxy of that massive size, that insanely fast, leaves us with a giant timeline gap. The gas out there just literally hasn't had enough time to fall together, cool down, and ignite into stars under the standard rules of gravity that we see locally today.
So, the crucial point is this. To force our standard dark matter models to actually fit this new JWST data, the required star formation efficiency would have to be greater than 100%. Just think about that for a second. You would literally have to convert available baryons into stars faster than the actual gas supply allows. There's no way around it that is a physical impossibility. Which means, either we have the mass estimates completely wrong, the observations are flawed, or, and this is where it gets really fun, the fundamental physics governing gravity in that early collapse is entirely different from what we assume in our local neighborhood.
Okay, moving into Section 1, Edge Modes and Locked Ratios.
This brings us to a massive potential paradigm shift called mode identity theory, or MIT for short. Instead of doing what we normally do, inventing exotic dark matter particles to fix the math, MIT looks at the actual geometry of the universe itself. Let's clearly define an edge mode. In MIT, observables aren't just random arbitrary numbers. They live on specific geometric manifolds. An edge mode, which we denote as n equals 1, references an evolving phase gradient scale. Just think of it like a clock ticking forward. As the universe's phase advances, the rules attached to that phase actually change. And the core idea here is that the Mond acceleration floor, known as A0, and the Hubble rate, h, are both edge modes. They are not independent constants floating around. They are tightly tied to the exact same evolving scale.
And because they share this exact same edge mode status, they occupy what the theory calls a 120-domain lattice. Basically, it's a discretization of a finite static universe. Specifically, they sit in Fibonacci wells right on this cosmic standing wave. You can kind of picture these wells like the frets on a guitar string. They are fixed stability points where destructive interference is minimized. So the acceleration scale sits at fret 13, and the Hubble rate sits way up at fret 34. And because they are vibrating on the exact same string, their values are mathematically locked together by their topological positions.
And this brilliantly illustrates the staggering power of that locked relationship. When you actually take the mathematical ratio of those two Fibonacci well positions, derived purely from the lattice geometry with zero adjustable parameters whatsoever, you get a predicted ratio of A0 over the speed of light times the Hubble rate of 0.184. Now check out our actual observed local value that astronomers measure today, 0.183. Crazy close, right? This massive coincidence was actually first noticed by physicist Mordechai Milgram way back in 1983. But for 4 decades, nobody had any clue why these two completely different cosmic scales were tied together so perfectly. Mode identity theory finally gives us an answer. It's because they are the exact same geometric object, just sampled at different stability wells.
Let's jump to Section 2, the ancient tide solution.
So we've established this mathematically locked ratio, right? Well, let's see what this actually means for those impossibly early JWST galaxies. Because that ratio is locked across every single epoch of the universe, it gives us an evolutionary law. It tells us that the acceleration scale, A0, at any redshift has to equal our local value today, multiplied by how much higher the Hubble rate was back then. Simply put, A0 tracks the exact evolution of the Hubble rate. It's not a fundamental constant at all. It actually evolves.
And here is where the math slams right into the JWS data. At redshift z equals 10, the Hubble rate was absolutely massive compared to what it is today. When we plug that high rate into our evolutionary law, we find something wild. The gravitational acceleration floor, a of 0, was a staggering 20.5 times stronger than our local value right now.
Just imagine that for a second. The baseline grip of gravity being magnified by a factor of over 20 in the early cosmos.
And because this gravitational floor was cranked up so high, it created what's called an ancient tide. See, in the Deepmon regime, the effective gravitational acceleration scales as the square root of A0. So when you take the square root of that 20.5 factor, you get an enhancement of about 4.5 times the effective gravity. And since freefall time scales inversely with the square root of gravity, this ultimately means early structures were collapsing roughly 2.1 times faster than any standard constant acceleration model would ever predict.
Now, what's really interesting about this is the beautiful final result it gives us. Remember that totally impossible, greater than 100% star formation efficiency we needed earlier to make the standard models work? Well, when you factor in this 2.1 times faster collapse speed driven by the ancient tide, the required efficiency to build those massive JWST galaxies drops right down to about 50%. And that is a completely normal, physically permitted range. Just like that, the impossibly early galaxy problem is completely resolved. No exotic physics needed, no invisible new dark matter particles to invent. The acceleration scale was simply larger when those galaxies were forming.
All right, moving to section 3, edge versus surface modes.
To really appreciate the elegance of this theory, we have to look at how it contrasts with standard cosmology. There is a really stark contrast here. In standard physics, you've got all these models trying to make the cosmological constant, lambda, dark energy, evolve over time, all while assuming A0 is strictly constant. MIT flips that completely upside down. It identifies A0 as an edge mode that evolves. But lambda? MIT defines lambda as a surface mode. It sits at a topological antinode. Basically, that's a geometric anchor point where the slope is absolutely zero. It's topologically protected, meaning it never, ever evolves. So you have one observable that's constant and one that is evolving, but both are measured from the exact same static cosmic standing wave.
Let's move on to section 4 and see how this builds into predictions and falsification.
Because at the end of the day, a theory is really only as good as its ability to be proven wrong. And the authors of this framework have laid out incredibly strict, pre-registered criteria to falsify the whole thing. Here is exactly how the framework dies. The upcoming Euclid data release is going to map weak lensing at high redshifts. If Euclid shows that A0 is actually consistent with a constant value at high redshifts, the theory is falsified. If independent probes show that lambda actually does vary, falsified. And finally, if a non-gravitational dark matter particle is ever definitively detected in a lab, the theory is dead. Honestly, it is so refreshing to see a theoretical framework put its neck on the line with such definitive, near-term, testable predictions.
Which brings us to our conclusion, perfectly captured by this quote directly from the source material. The galaxies found too early were formed under a stronger tide. By locking the acceleration scale to the Hubble rate through pure geometry, a massive field-breaking cosmological headache might just vanish into simple, elegant mathematics. It leaves us with a pretty profound question to ponder as we sit around waiting for that Euclid data to drop. If the very baseline of gravity's acceleration is tied directly to the ticking phase clock of the cosmos, what other constants in our local universe are actually just a temporary reflection of the epoch we happen to be observing from? Thanks so much for joining me on this explainer. Keep your eyes on the stars, and I'll catch you next time.